Hello, welcome to our video about tips for question number 6 in quiz 5. And basically I'm having you interpret a number of different kink demand curves, and I'm giving you the equations for those demand curves. So let's just go over a simple equation for a demand curve, and it could look something like this. P equals 10 minus Q. Now, if you notice, this looks surprisingly like a formula for a linear curve. The formula for linear curve is going to be y equals a minus bx. Okay. In this case, x and q are the equivalent, and y and p are the equivalent in this particular example. And so what we're going to do, oops, sorry, get this out of there. What we're going to do is I'm going to erase what I just did. And I'm going to show you how we could graph this line. So we need a x-axis, a y-axis and an x-axis. And for the y, we're going to put p, and for the x, we're going to put q. And we need numbers here, so let's just call this, make this over here. So we've got 2, 4, 6, 8, 10, 12. And over here we've got the same thing, 2, 4, 6, 8, 10, 12. Now, the easiest way to graph this line is to find the x and y intercepts, or where the line crosses the vertical axis, values for p, and the horizontal axis, values for q. And the way you do that is, if q is 0, that means we're going to be right here on the curve, because this is 0 right here. If q is 0, then the equation here is going to be p equals 10. So we've got a y-intercept of right here of 10. Now, what if we make q equal to, p equal to 0? Well, if p equals 0, that's going to equals 0, 10 minus q. Now, what we'll do is we'll solve for q. So we'll bring q over to here by adding q to both sides. When you add q to this side, it cancels it out, and so we've got q equals 10. And so this is symmetrical. It just so happens that this is symmetrical. This is just coincidence. So when p is 0, q is 10, and we've got a straight line that looks like this. And this is the demand curve and the equation for this demand curve is p equals 10 minus q. That's what this is right there. And so what I'm giving you in the, let me erase some of this, and let me make this a little bit bigger. Hold on. Well, it's going to take forever to erase this. How can I make my eraser bigger? I know what I'll do is this. And I'll make this huge like there. This again is going to take forever. I wish I know how. This is a new paint program. Oh, brushes. I'm going to put on a new brush. And this is help. I apologize for this. I'm having little problems here. I'm just going to start a new file. So let me just go a new one. Don't save. Okay, we got a blank slate. Let me just make my a little bit thinner here. And so we got a kink demand curve that looks like this. Here, it stops here and then goes like that. So you can see this demand curve has two slopes. You got a demand curve that hits here, and this has its own equation. And then you got a demand curve that hits here and it's got its own equation. So if I were to keep drawing this demand curve, it would look like this. Let me just change my brushes here. So it would look like this. So this would be the line for the flat curve. And this has its own slope. And you could go through the same process in figuring out the vertical axis intersection and in this case, the horizontal axis. So I'll extend the horizontal axis out like this, right here. And you can get the slope of this curve. And look at this steeper demand curve right here. So it goes up like this. And you got this vertical axis intercept here and a horizontal axis slope here. And you could go through the same process in terms of finding the vertical and horizontal intercepts, and that's going to help you solve question number 6. So email me if you have any more questions.